Hello everyone, welcome to VGDA's Toolkit. I'm Josh Shucker, and today we're going to be talking about Git and GitHub. Now they're two slightly different things, so let me explain the difference. Git is a version control system. There are lots that exist, but we're going to focus specifically on Git. Now, version control systems are helpful because they take snapshots of the project at different times, and they can also track the changes that take place between those. So that allows multiple users to work on the same project without accidentally damaging each other's code. And it also means that if something does get damaged, you can roll back to a previous version and everything's okay. Now, any project that you're working on using Git is referred to as a repository. And if it's on your computer, it's referred to as a local repository. Now, this distinction is necessary because GitHub is a website that allows you to store repositories online. When they're stored online, they're referred to as remote repositories. And remote repositories are useful because it allows all the users who are working on the project to work on it without being on the same computer. If you're not using GitHub and you're just using Git, everything is stored locally on the computer and all the users have to be using that computer. So that's why GitHub is particularly useful. So let's go and take a look at how you can download Git and GitHub. Alright everyone, so here we are at the GitHub website. It's just github.com right here, pretty easy to find. Now what you need to do is you need to sign up for an account. So you pick a username, you put in your email address, you make a password, and it's also going to ask you if you want a paid version or a free version. The only real difference that I've found is the paid version allows you to create private repositories that other people can't access. In most cases, you're going to be working with other people who need access, so unless you're really paranoid about people stealing whatever project you're working on, you can probably get by with a free account. If you are paranoid, though, by all means, get a paid account. There's nothing wrong with it. You're also going to need the GitHub desktop application. That can be found over here at desktop.github.com. You want to download that. There's a version for both Windows and Mac. And it's an application that will allow you to do a lot of the really complex stuff that Git would normally do in a simpler way. When you download it, it's going to come with the desktop application, and it also comes with a Git shell application. That will open up a command prompt that lets you run what's actually true Git. It's a little more complex, though. It allows you to do anything in the Git shell. You have complete control, whereas the desktop application only can do certain things. But the downside to the shell is if you don't know what you're doing, you can do some serious damage to your repositories. So we'll start with the desktop application. We'll move on to some information about the shell afterwards, and then you can go with whatever you feel most comfortable with. So let's go ahead and start by creating a repository. Alright everyone, so now we have our GitHub desktop application, and we have Git shell. Open those up right down here. We'll get back to those in a second though. Right now, we're going to go ahead and make a new repository so that we can start doing some work. So this is the GitHub website. I already logged into my account. And right down here, there's a little button that says New Repository. So we're going to go ahead and click that. You just go ahead and put in the name of the repository you're creating. This is whatever you want to call it. It helps to call it something that you can remember. So I'm just going to call this Demo Project. There we are. You can put in a description if you like. I usually don't. You can also choose whether it's public or private. Now, this was what I was talking about before. If you choose private, it'll ask if you want to upgrade your account to a paid version. If you have the free version, you're stuck doing public, but it won't really hurt anything in this case. And you can also choose to add a git ignore. Now, the git ignore is a little file that gets stored in with the repository, and it tells Git what files it can skip and what files it needs to take a snapshot of. Now, this is particularly useful because you don't actually need to save all the files, you just need to save the ones that might change. So, since we're going to be building all of our VGDA projects in Unity, it turns out there is a Unity git ignore that they already have set up for you. So select that and create the repository. And there it is. So this is our demo project repository right here. And you can make all sorts of changes from the website, but let's actually start working on it from the computer now. So here is the desktop application. And if you notice right up here in the corner, you have this plus sign, which can create, clone, or add a local repository. Now, we already created the repository remotely, so we don't need to create or add, because that would involve something that's already on the computer. We're going to clone. So, you open it up, you pick yourself, which that's probably the only thing listed there. Then over here, so you have add, create, and clone. You're going to hit clone. You're going to find the repository that was just created, which is demo project, and you go down here and hit clone demo project. and it'll ask you which folder you want to save that into. You should have a GitHub folder, and I just have mine under my documents. And all your projects are going to get stored in there. Be sure you put it somewhere that you can find again, because there are times you need to go and find that GitHub folder. So we're going to go ahead and clone that. There's nothing in it right now, so it clones very quickly. If it were a larger file, it might take quite a bit longer. So we have our demo project, and the initial commit is there. That's just the git ignore that we asked it to put in there for us. So right up here, this little timeline is showing every commit that's been made, and each commit is a change that takes place on the repository. Now, anytime this is the demo project, but it's only a local repository right now. It is tied to a remote repository on the website, but any changes I make to demo project are only happening on my computer. Now, this button right here, sync, that says it pulls changes from and push local changes on master to the remote. So what that means is that anytime I hit sync right here, which right now it's not going to do anything, but I'll just show you, that's taking anything on the website that's changed and putting it into my repository locally, and it's also taking any changes I've made and it's moving those to the website remote repository. So what it's doing is it's making sure that the local repository on my computer and the website's remote repository match up with each other. They should be identical after you hit sync. So just be sure to do that anytime you've made some changes. If you don't do that, then everything will be updated, but it won't be updated on the website. So now we're going to start doing some work inside Unity. Alright, so now we have Unity open here. We need to create a new project that we can store in our repository, because right now the demo project, even though we gave it a Unity git ignore file, there's still no Unity project in there. It is an empty repository. So let's actually put a Unity project in there. We're going to make a new one for it. We're going to call this, we're going to call it demo project again, actually. And it doesn't matter if the name of the Unity project is the same as the repository name. It won't hurt anything. You can name them different things and it still won't hurt anything, but I like naming them the same thing just for simplicity. We're going to make it a 2D project just because it's easier to deal with for me. And we're going to save it in my Unity projects folder. Alright, so we'll go ahead and set that up. And here we are. So this is our new project. Now, there's a few things that you need to set up every time you create a new Unity project that you're planning on using GitHub with, because it needs some things so that it functions properly with it. So, here's what we're going to do. First up, you want to go to Edit, Project Settings, Editor, and then over here you have Version Control, and you need to set the mode to Visible Metafiles. The metafiles just kind of track the actual project files, and they track the changes that take place with them. And if the GitHub can't find those, it can really cause some issues, so you always want to set those to visible. And then also down here under Asset Serialization, you want to put Force Text. These are just the things you need to do so that GitHub is happy. So once you've done that, now everything's kind of ready to be put into the repository. There's a few things that I always want to do, though. Even though this is an empty project, since lots of people are going to be working on it, I usually want to set it up in such a way that it is already prepared to do work. So first off, you have your assets folder. I always create a few folders within that just for all the things that are going to be added to the project. So I usually make one for graphics, I'll make one for scenes, I make one for scripts. Yeah, and you don't have to do this, it's just my own personal thing, but I find it easier. Maybe one for, music, or sounds. Yeah. Oh, and you always want to make one for prefabs as well. Just so you have some things you can grab back out. If you don't understand prefabs, we have a Unity video you can watch about that. And then also, as of now, you have no scenes because nothing's been built. But you're on this untitled scene that opens up when you first boot up Unity, so I'm going to go ahead and save that scene in the scenes folder that I created, and I'm going to title it Test Scene. This just makes it easier on anyone else who's opening up the project later. They can open up the repository file, and rather than booting up Unity, opening this project in Unity, they can just double-click the scene file and everything will open up all at once. I'll show you that in a little bit. So now if you go down to Scenes here, there's that test scene, and you can open it up. There's still nothing in it, but it doesn't hurt anything. So now that we've got that, we can add this into our repository. So I'm going to go ahead and close out of Unity. And we're going to navigate to that same folder that I had before. So, Documents, go to Unity Projects, and there's that nice demo project folder right there. And then we're also going to go to the GitHub folder, and I still have my demo project repository there. So this is the inside of the demo project repository. There's nothing in there other than the Git file and a text document. And what we want to do is we want to take all of the internal files from the demo project Unity project, and we're going to just drag those over. Actually, we're going to copy those because I don't want to permanently remove them from that file. Alright, so that copies everything over. And now the GitHub repository has the project that I've been working on. And if you look at the GitHub desktop application, you'll see that there's this little changes spot and there's a dot there. What that means is that there are uncommitted changes, and it even says view 24 uncommitted changes. That's just to indicate that right now there's something that you've changed in the repository and it hasn't been saved. So if we click that, it actually shows you every change that you've made. You can individually click on each one, and it will show you what those changes are. Now, a lot of these don't really make a lot of sense to us because these aren't code. These are internal files of Unity. So don't worry about these too much. If there's something that you see that you definitely don't want to change, like for instance, if later on you're working on code and you notice that like the test scene has changes to it, but you didn't do anything in the test scene and you don't want that, you can right-click it and hit discard changes, and that will just throw that out. And the next time you open up this project from the GitHub folder, you'll find that those changes aren't there anymore. So be careful not to discard anything unless it's something that you really, really don't want. If you decide that everything you did was terrible and you don't want any of it, you can actually right-click at the top here where it says 24 changes and hit discard all changes. Again, don't do that unless you want to get rid of them, but sometimes you don't like the changes you made and you want to get back to where you were. So, now that we made these changes, you're going to need to create a commit. And the commit is the snapshots that I was telling you about earlier. So, to commit all of this work, you're going to go ahead and title it. I'm just going to title it Added Project File. The commit, you want to give it a title that is distinctive, something that people will understand. So anyone reading this would know that that commit is adding the original project file. I can just call it initial, actually. Initial project file. And then the description, you would normally detail every change that you made so that people can go back through and kind of have a list of all of the changes that took place at each commit. Again, since I just added the project file, I'm just going to say I added the initial project file from Unity to the repository. And I can't spell. There we go. And then you hit commit to master. It'll take a second to commit, and once it does that, it adds this node right up here. And you can see that I have my initial commit, that's when I added the git ignore, and now I have my new one, which is when I added that initial project file. But you'll notice that that node is open. Now what that means is that this is a local commit. So it's been committed, it's saved, but only on your computer. Now if you want the online repository, the remote repository, to reflect that, then you need to go ahead and hit sync. And it'll take a second to sync. And you'll notice that when this bar finishes, that node will fill in. And there you go. So now anyone else who would download this repository or sync their repository would get these changes because those are reflected on the remote repository. So now that we've done that, let's talk about branches a bit. So as of now, we are on the master branch. Now normally when you're working on a project, the master branch is the final version of the project. It doesn't necessarily mean it's done, but what it does mean is that anything on the master branch is considered finalized. So we don't want anything on the master branch that's broken. So if you're planning on doing some of your own work, you should not be working on this master branch. If you look over here, there's a little button to create a new branch. And if you click that, it gives you the option of naming that branch whatever you like, and it's telling you where that branch is coming from. So what the branch is doing is it's splitting off from the master, and it's creating an exact copy of it at the time you made it. So if I make a branch right now from the master, it will be an exact copy of the master, but if other changes are made to the master later on, those won't be on my branch. So it's just a snapshot of what's there currently. Now, let's say I was working on the controls for the game. So I'm going to name this branch controls. Can't spell again. There we are. You want to name it something that's distinctive so you don't forget. And there's also some things you should pay attention to when you're naming it. Don't put any symbols in there, that can kind of screw things up. And also make sure you don't put any spaces either. Git likes to convert spaces into dashes because the name does need to be all one thing. And when it does that, it can kind of screw up the Git shell later on. A lot of the commands that you run in Git shell involve putting a dash and then a letter or something after it. So sometimes it'll have trouble recognizing your branch name because it sees dashes. So make it all words. So if it was like player controls, you do like controls player or something like that, but no spaces. Okay? I'm just going to call it controls though. It makes things simple. So we're going to go ahead and create the new branch, and you're going to notice that it's kind of broken off from the master into its own timeline here. So this is my copy, and it is a publish button here. Now the reason that's appeared is because when you create a new branch, it's only made locally. It is not on the remote branch, and if you want it to be backed up on the remote branch, which you do, you're going to go ahead and hit publish, and that will sync your branch to the remote so that now, if somebody else were working on the project elsewhere, they could potentially switch to your branch. This is particularly useful because if, say, you mess something up, you can delete this and then bring your branch back down from the remote, and you have all your work again. Or if the project lead, whoever that may be, needs to check out your branch and find out what's wrong with it, or maybe make some changes to it, they can get on your branch successfully without being on your computer, which is kind of crucial. So, we're now on a branch. Let's make some changes. So I'm going to go ahead, if I need to get into Unity, you can just right-click on the repository over here, and if you click Open in Explorer, it'll open up your GitHub project file. So here is demo project, and I can just go into Assets, Scenes, and there's that test scene that I created. This is what I was talking about earlier. It's easier to access because I can just double-click this, and it'll automatically open up Unity for me to exactly where I want to be, rather than having to open it by starting Unity and then choosing the proper file. So, here we are in Unity, and we're going to make a few changes to the scene just so there's something that you can commit. So we're going to go ahead, let's just drop a game object in here. So we're just going to call this the player. I'm not really going to give him anything that we need to do. I'll give him an image so you can actually see him. You don't have to worry about what I'm doing here. Like, if you need a better understanding of how Unity works, like I said, there's the Unity tutorial, and that'll cover everything you really need for that. This is just really focusing on GitHub. So, we're going to make a new script, call it player controls, and I'm not actually going to write any controls here. You can see it's created a new script. It has the start and the update method. I could go in there and write some controls for it, but you know what? Let's not worry about that right now. That's something that we can do in the Unity tutorial. So, you got a script, you got a player. I'm going to go ahead and give the player that script just so there's, you know, something connected to him. And we'll go ahead and save the whole project. Now, if we go back to the closing things. If we go back to GitHub desktop, you'll notice that we have all these changes now. You can see the playercontrols.cs file. That's the code that we just wrote. There wasn't much of it, but it tells you exactly what the code is right here. Anything that's green is something that was added. Anything that's red is something that was removed. So if I was using a script that was already there, I could go in there and, you know, delete some code, add some new code, and it would show everything right here. So you could always kind of review the changes you made and make sure you didn't do anything accidentally. Here's the cs.meta. These are the files I was telling you about that Unity has to include. Any changes you make, if there's a meta file that is changed along with it, make sure you commit that. It's pretty important. And then the test scene right here has changes to it because I added that character to the test scene. If you're making changes to things and they don't need to be in the test scene, or in whatever scene it happens to be you guys are working in, then I would recommend, instead of actually changing the scene, or you could actually change the scene if you want, but let's say I just needed to create a player, and I didn't need to put him in the scene. I could do everything I did here, and then I could take that player and drag him into the prefabs. So now there's a saved version of that player, and I can delete the player from the scene. And then if I go back to my changes, it's added that prefab as a change. And the scene has still been modified, even though it's back the way it was, so I can delete the changes in that scene. And now I'm only committing a player prefab and player controls. So I haven't actually hurt the scene at all. And that's really important because changes to code, GitHub handles pretty well. It doesn't really have too many issues with that. Changes to scenes, it does not like. I mean, if you need to make changes to the scene, I would recommend doing it in a separate scene. That way, there's no way you could conflict with someone else's work. But if somebody else changed something in the scene and you changed something in the scene, it doesn't know which one is supposed to be correct. So it has trouble figuring out what is actually the thing that it needs in the scene. So quite often, if someone else made a change to the scene, and then you try and commit a change to the scene, it'll have a merge conflict, which I'll get to in just a second, but it'll create issues. So, right now we have our changes. I'm going to go ahead and commit that, and I'm committing this to my own personal branch, not to the master, and that's very key here. So, added player prefab, and then under here I'm going to say created a new player prefab, created player control script, added controls script to player. So that's all the changes I made. It's a nice description of it. That way people understand what's taking place. We're going to commit that. We're going to sync it again because we want this to be reflected on the remote repository. Wait for it. And it's done. Now, let's say I wanted those changes to now go into the master. Let's say I was assigned a task, I finished it, I like how it works, and I've tested it. Make sure you always test your work. Don't try and commit anything that doesn't work because people will get angry. I've done it myself. It's not a good thing. So, I want these changes to now be part of the master. But you don't want to just commit them to the master, because if there's someone who is in charge of the project, they're the ones who have final say of what goes into the master. So instead, we're going to do something called a pull request. And there's a button for it right here. When you click that, it opens up a nice little menu here, and it actually fills in everything from my last commit. You can change that if you want to kind of sum up everything that took place during your work, but if you only have one commit, I mean, this kind of works out. Anyways, I'm just going to rename it for simplicity, so we're going to call this committing controls task. And then you would list everything you did here. Down here, it'll tell you whether or not your pull request can be automatically merged. If you did everything carefully, hopefully it can. If it can't be, that doesn't mean you shouldn't submit the pull request. It just means that there's something that's going to conflict with other work that's been done, and whoever is the project lead is going to have to handle that. If you kind of follow the instructions I've mentioned, though, like avoiding making commits to a scene that other people are doing work in, you should probably be able to avoid that. But, you know, just, it can happen. There's going to be merge conflicts at some point. So, we're going to go ahead and send this pull request. So this means it hasn't actually made the changes. You'll notice that up here, there's that nice little connection back to the master, but it's dotted. It hasn't actually happened yet. It's just requesting to be added into the master. Now, this part you won't handle if you aren't the project lead, but I'm going to go over it anyway. Just disclaimer, if you're not the project lead, don't do this. So, we're now back on the website, and you'll notice that now I'm back on the repository. You have the commit. This was the initial commit that I made with the initial project file. And up here, there's something that says pull requests. And there's the request that I made. It'll tell you who made it. It'll tell you whether or not it can be merged automatically. If you go to commits here, it shows all the commits that took place on that branch. And if you go here, it shows all the files that were changed. And you can actually see any script changes that took place, everything. It's all there. Comments can be made on the commit. So if the project lead finds issues with it, they can respond to you and let you know what's wrong with it. And here is how you would merge the pull request right here. That's what takes the code changes that you made and adds them back into the master file. Now, again, do not go do this unless you are the project lead. But let's pretend you are for a moment. So if you're the project lead, you would just hit merge pull request. You would confirm it. And now it's merged and closed. And you can delete the branch now because that branch's work has been committed. We don't really need it anymore. I'm not going to bother with that, but it is good to delete branches when you're done with them just so they don't pile up. So now, back on the GitHub desktop application, if I switch back over to the master branch and I hit sync, the little bar will go again. And if you just watch right here, you'll notice it adds another node, and this time it looks a little bit different. That is a merge pull request. So that indicates that a branch was merged into the master. And it shows all the changes that took place. It's just like a regular commit, but it came from a branch instead of from someone working on this branch. Alright, so this concludes everything involving the GitHub desktop application. Next up, I'm going to be talking about the Git shell. It's a little bit more complex, and honestly, if you don't feel like going through this, everything you've learned so far should be enough for you to handle any task you might be given in VGDA. This is important stuff, though, and I would recommend continuing. It'll give you a better understanding of Git, and it also will be particularly useful if you start looking for tech jobs, because knowing how to use some sort of version control system is pretty crucial. So, moving on, let's talk about the Git shell. So, what we have here is the Git shell. The Git shell handles all the same things that the GitHub desktop application can do, but it also handles quite a bit more than that. And one thing before we start, the Git shell does run like a command line. So if you're unfamiliar with command line syntax or bash commands or things like that, some of this may be a little new to you, but I'll explain as much as I can here. So when you first open it up, it starts off with a command prompt, kind of like this. It's very similar to like the Windows command prompt. In fact, that's basically what it is. Now, you need to navigate to the folder of the project you're working on, because the Git shell will automatically open up on your GitHub file. You'll notice here it's my file is located at C, users, Josh, documents, GitHub. But that is not the project we've been working on. That is just the main GitHub folder. Now, within like Windows command prompt, to navigate to a file, you use the command cd and then space and the name of the file that you'd be entering. So since the file that I stored everything in is called demo project, I would cd demo project, and it needs to be spelled exactly the same. And when you do that, you notice it now navigates to that directory, and in these brackets here it shows that we're on the master branch. So there's a lot of commands that can be run in the Git shell, but one thing that you can almost always count on is the command almost always starts with git. So some simple ones. Git status is an important one. You can run that all the time. It doesn't hurt anything. It just shows the current status of the branch you are on. It shows whether or not you are behind or ahead in commits. It shows whether or not you have uncommitted data. It's just particularly useful. Some other ones. Git branch lists all the branches that are currently on your local repository. Right now I have controls, player movement, and master. Now if there are lots of branches that have been made, but you don't have them on your computer, then git branch will not list those. However, git branch -a will. That will list every branch that exists. And there you have it. Those are the ones that are the remote versions. See, so we have controls locally, we have controls remotely, we have player movement locally, player movement remotely, and so on. It's particularly useful if you just need to know what branches exist. Then, let's see what else we have. If you need to merge one branch into another, so like if you were doing a merge from your branch into the master, you would type git merge, and then the name of the branch. We're not going to do that right now, we'll get to that in a second. Git fetch is particularly useful. That retrieves the data of the remote branches. It's not going to do anything right now because we have all that data. Git pull is kind of like git fetch. It's a little different though. It combines git fetch and git merge. So what it's actually doing is it is pulling, it's fetching all the data from the remote, and then it is merging all the remote data into your local data. So it's taking all of your local branches and updating them. And then git push, so we have git push, that takes everything locally and pushes it to the remote branches. So when you're on the GitHub desktop application and you hit sync, sync is actually combining a git push and a git pull into a single task, which really simplifies things. But the nice thing about being able to do them here is you can choose exactly what you want to do. You don't have to do it all at once, it's very specified. So let's start doing some work. Right now we're currently on the master branch. So let's say we wanted to switch branches. I already have a branch called controls, so we're going to type in git checkout. Checkout is what allows you to access another branch, and then you type in that branch name exactly, so controls. It says that I switched branch to controls, my branch is up to date, and it now lists that I'm on the controls branch right here. Now let's go ahead and do some work on the project. I'm just going to change something. It doesn't really matter. We're going to add a new script. Okay? I'm not even going to attach to anything. We're just going to create one. Test script. There it is. And if we go back, now let's take a look. Just git status. And you'll notice, there we go. There are some uncommitted changes. Now, we'd like to commit those changes, but we can't do that yet because these files are untracked. We need to track them. So it even says right here, we need to git add file. So we'll start git add, and you want to type in that file exactly. So assets, scripts, test script.cs. Like I said, got to be exact. Alright, and then we also want to add the other one. Gotta have the meta files, can't forget those. Okay, and now you notice that there's nothing red anymore. It shows +2, nothing red. That means you're 2 commits ahead, basically. Or not 2 commits, 2 files are being committed. So now we want to actually create the commit. So we type in git commit, and then -m. The dashes are always like modifiers on the command. -m means we're going to add a message. And you put quotes, and then you type in what you changed. So add a test script to script folder. And now we can commit that. Alright, so that's now been committed. And you'll notice it's green. What that means is that we haven't actually committed it to the remote repository, we've only committed it to the local one. And we want to push this. So we're going to go ahead and do git push. Just like so. And that sends it up to the remote repository. Takes a second, and you can see now it's gone back to blue. And it has committed that to the website, which is what we want. Now, if you want to take changes from your branch and put them in another, you're going to use git merge, like I said before. Now, the thing is, when you try and merge a pull request, if there are those conflicts that I talked about earlier, you can't actually merge it unless you are in the Git shell. So I'm going to show you how to handle some faulty merge stuff. Alright, so now I'm going to show you how to solve the faulty merge issues. And I'm going to use a different project file for this because creating issues that cause those merge conflicts can get a little messy at times. It's much easier just to use a project where we already have a few. So, we're currently working on Echoes of Tikkun. This is the project file for it. And right here is a pull request that was unable to be merged. We've already handled stuff like this in the actual game, but this is an old one, and I'm just going to use this as a demonstration. So, the branch is called Mobile Slide Down, and what we're going to do, right now I'm on master. First I'm going to check out, git checkout, Mobile Slide Down. Let me be sure I spelled that right. No, I did not. Okay, so now I can be sure that I've got the most updated version of Mobile Slide Down because I don't want to be using an old version of the branch. We're going to switch back over to the master. And so now we are going to try and merge Mobile Slide Down into master, and it's going to fail. We already know that because if we look right here, it says this branch has conflicts that must be resolved. So, we're going to give it a shot. So watch, git merge Mobile Slide Down. Ah, that matters. Okay, so git merge mobile slide down into master, and it fails. Now that's important, and you'll notice right here it says conflict content merge conflict in assets scripts player controller.cs. So what that means is there's some sort of conflict in that particular file that is preventing the merge. It's the only one listed, so that's the only thing we need to fix. Now there's two different ways we can fix this. Our options are either keep the one that's already on the master, or take the one that's coming from the branch that's being merged. So it depends. The question is that something we actually want to change? So the way we'll handle that, let's say we wanted to take the one that is already on the master. Now, no matter what, the way we handle this situation is we take the file from the respective branch that we want and we add it to the commit. So let's say I wanted the one from the master. It's really simple. I'm already on the master branch. I just say git add, and then I'm going to put exactly that file name. So let's do this. We do assets, scripts, once again, there we go, player controller.cs. Okay, so we do that, and then once you do it, you'll notice now there's no red text there. So that means that there's no more conflicts. We've added that file in, everything should be fine, and at this point you would do git commit -m as usual, put in a message, so merge this mobile slide down branch. You commit that, and now the merge conflict has been fixed. The merge has been done successfully, and the only thing you still need to do here is you need to push it to the master. So you type in git push. I'm not going to do this because I don't actually want to push any of these changes because I don't know if this branch is ready to be used or not. Alright, so let's pretend everything else we just did didn't happen. So we're back to where we were. I just tried to merge in mobile slide down into master and it failed. Now this time around we're going to pretend that I want that version of the player controller.cs file that's in the mobile slide down branch, not the one that's in the master. To handle it, you do it almost the same way you handled it when you wanted the version that was in the master branch. There's only one different line of code that you have to add. So we're going to go ahead and, even though we're on the master branch, we're going to type in checkout, git checkout, mobile slide down. And the difference here is if I were to type that in just as so, it would switch me over to the mobile slide down branch. I don't want to do that. I want to check out just that file from the mobile slide down branch. So we're going to type in assets, scripts, player controller.cs. So that's going to be grabbing only that file from the other branch, and that's what we want. And you notice that fixed the merge commit as well. Once again, the red is gone. We're all in the green now. You type in the same thing as before, so git add. It's kind of a lengthy name as always. There we go. Add assets player controller CS. That adds it in successfully. And now we go ahead and git commit -m, and once again we just commit it with a message describing what was done. Once again it's successful, and then we would just type in git push like I mentioned before, and that would upload it to the remote repository. Alright, so that's all for this video. Thanks for watching, guys. Check out our other videos, and let's make some awesome games.